Okay, we're going to look at some review problems for our upcoming test on Module 6. So the big thing we did in this chapter, besides the unit circle and finding some exact values, is we did a lot of graphing. So this function, we have y equals negative 1.5 cosine 3x plus 3 pi over 2. So the amplitude, remember the amplitude is always the absolute value of a, and a is the number in front. So the amplitude for this one is the absolute value of negative 1.5. So it's just 1.5. So that's the distance from the midline to the top and the bottom. But we do know it's flipped. So remember sometimes we wrote flipped just to know that it's going to flip over. Period is 2 pi over b. And b is the number in front of x. That's our big thing that changes the period. So in this case it's 2 pi over 3. Our phase shift, remember, is the opposite of c over b. So b is still 3, but our c is the 3 pi over 2. So our phase shift is negative 3 pi over 2 divided by 3. So remember, when we're doing this, we can multiply by the reciprocal. So that changes the multiplication of 1/3. So that becomes negative pi over 2. Vertical shift is d. That would be a value at the end. There is none in this case. No vertical shift. So when we start to graph it, obviously your graphing utility is a pretty good tool. But when we're graphing it by hand, remember we would always start at the phase shift. So we're going to start at negative pi over 2. And we're going to end at the phase shift plus the period, which is 2 pi over 3. So we'll have to add these fractions, getting common denominators. So that would be 3 pi over 6 and 4 pi over 6. So that would be pi over 6. Just getting common denominators. So if we look down here on our grid to try to graph this, I know the middle is just going to be 0. And the amplitude is 1.5, so our top line would be here at 1.5. And our bottom line would be down here at negative 1.5. Now on this grid, every unit is pi over 12, so each of the little marks is pi over 12. So if I want negative pi over 2, I'm going to go to 6 pi over 12. So I'm going to go back 6. 1, 2, 3, 4, 5, 6. So here's negative pi over 2. And since pi over 6 is my ending point, that's just 2/12, so there's pi over 6. So if I want to find the middle of those two, I certainly can. So that's 8 spots in between, so we'll just go 4 spots. So this would be my middle. And then here would be the middle of that, and here would be the middle of that. So those are kind of my key points. So it's a cosine graph flipped, so it is going to start at the bottom at my first key point. Then it will travel to the middle, to the top, back to the middle, back to where it started. So there is my graph of that function, one period of that. And you could do more periods if you'd like. Let's look at another graph. This one is y equals 3 sine 1/3 x plus 1. Very similar to the last problem. So amplitude is 3. That's the number in front. Period is going to be 2 pi divided by b, which in this case is 1/3. So that's 2 pi times 3 over 1, so 6 pi. So a really long one. This one's going to be a pretty easy one because there's no phase shift, because there's no c. Because remember, the c would be added after the x. And the vertical shift is going to be up 1, or plus 1, because of the plus 1 at the end. So the starting and ending points are relatively simple here. I'm going to start at 0 because there's no phase shift. So I'm going to start at 0, and I'm going to end at 6 pi. So the middle of those two would be 3 pi. In between those is 1.5 pi and 4.5 pi. So those are my 5 key points. So my midline in this case is 1. So let's just kind of put a dashed line at the middle. And then my amplitude is 3. So from 1, if I go up 3 from 1, I'm at 4. So there's my top line. And if I go from 1 and I go down 3, I'm at -2, which is this point down here. So this is a sine. So remember, sine starts in the middle. It's not flipped, so it's going to go up. So the next key point, I'm just going to be at that top line. And again, make sure you're going back to the midline because the new middle is 1, not 0. Back there, and then back to the middle. So here is 1 period of my sine function. Okay, so let's look at this next one. It says, I want to find the equation of the graph below, justify my answer. So we could do these several ways that we've seen as sines or cosine. I think the easiest way in this case is to do it as a cosine. So we're just going to look at this portion of the graph. So if I go from beginning to end, I'm starting at 0, and 1 period goes all the way to 16 pi. So 1 period in this case is 16 pi. So if I look at the amplitude, I believe the middle is still 0. It's not moved any. So if I'm going up and down, my amplitude is 3. So I have a cosine function with an amplitude of 3, a period of 16 pi. I don't seem to have any shifts up or down, and I don't have any shifts left or right, mainly because I'm starting at 0. So this one will be a relatively straightforward one to make. So our graph is going to be f of x equals 3 cosine. Now again, it's positive because it's not flipped. And then I just got to figure out the number to put in front of x to make the period 16 pi. So remember, the period for a cosine or a sine graph is 2 pi over b, and b is really the number I need here. So I'm trying to figure out what number divided by 2 pi will give me 16 pi. Lots of ways to do this. You can cross multiply, do something like this. Get 16 pi b equals 2 pi. Divide both sides by 16 pi. So the pi's cancel, 2/16 reduces to 1/8. So that 1/8 is the number that when I take 2 pi and divide it by, I get 16 pi. Now, you could have also done this one as a sine. Would have been a little trickier, but the same basic concept. You could have phase shifted it over 4 pi and done a negative flip sine curve. But cosine is definitely the easiest one to do in this case. All right, so this one is a multiple choice question. You can see where it is one of our other trig graphs. Now, the first thing I noticed about it is all these graphs are going down. They're decreasing, and typically cotangent is the one that goes down versus tangent. So I would kind of eliminate, it's obviously not secant because secant is the alternating parabolas. So I would probably eliminate tangent. So it's either going to be cotangent of x or cotangent of 2x. But the period of this, if you look at the period, just one wave is between 0 and pi over 2. So the period is pi over 2. Well, for a cotangent, we said that a general cotangent graph, cotangent and tangent are the different ones because their period is just pi over b. It's not 2 pi. So what number do I need to put under pi to get pi over 2? Well, it need to be 2. So this is a graph of cotangent 2x. Now, of course, you could just graph these and see which one matches best, but just using a little bit of logic, we could kind of pick which one is our graph. Okay, number 5 says, where does this function have vertical asymptotes? So this one has that factor of 2, so that's changing the period and the asymptotes. So recall, for a typical cotangent function, we have a period of pi, and vertical asymptotes for cotangent typically appear at k pi, where k is an integer, any integer. So those are always good to know where your vertical asymptotes are. So when we have this number of 2, we're just going to divide both of these by 2. So my vertical asymptotes will turn out being at k pi over 2, where k is any integer. So if I want to start picking integers, if I pick 1, I get pi over 2. If I pick 0, I get 0. If I pick negative 1, I get negative pi over 2. If I pick 2, 2 over 2 is 1. If I pick 3, I get 3 pi over 2. I mean, I can do this all day. All these are going to be asymptotes of cotan 2x. So what I would make sure you have written down on your note card, make sure you know the generic vertical asymptote formulas, and then you can change them for those other 4 trigonometric functions. All right, for this last page, we're going to kind of go back and do some of the stuff that we talked about on that first quiz. So number 6 says, given an angle theta in quadrant 4 with tan theta equal to -3, find the value of the other 5 trigonometric function values. So the big thing it says here is we have an angle in quadrant 4. So anytime we do that, we're typically going to draw a triangle. Here's my reference angle, which we know will have the same sign as my trig function value except for some signs. So tangent is opposite over adjacent. So there is no adjacent really, so we'll just put it over 1. So we have -3 for my opposite and 1 for my adjacent. So now, of course, I have to use Pythagoras' theorem to find the hypotenuse. So c squared equals 1 squared plus -3 squared. So that's 9 plus 1, that's 10. So c squared equals 10, so c equals the square root of 10. That's my hypotenuse. So once you have your triangle set up, it's really straightforward. We're just going to find the sine, the cosine, the cosecant, the secant, and the cotangent based on this triangle. So remember, sine is opposite over hypotenuse, so that's -3 over radical 10. And if you want to rationalize that, that's -3 radical 10 over 10. The cosine is adjacent over hypotenuse, so that's 1 over radical 10. So that's radical 10 over 10. The cosecant is just the flip of sine, so that's radical 10 over -3. Secant is the flip of cosine, so that's radical 10 over 1. And cotangent is just the flip of tangent, so that's -1/3. So your key thing in a problem like this, if it says an angle is in a certain quadrant, just draw a triangle, find the sides, and then find your different ratios. All right, 7, and kind of the rest of this, kind of just talk about the different ways we can use the unit circle. So the first one says, given the angle theta equals -120, state the reference angle and one angle coterminal to it. So the coterminal is real simple. Coterminal, we're going to either add or subtract 360. So in this case, since it's negative, I think it would be to our advantage to add 360. So that's 240 degrees. So if we graph this, we know -120 is over here. So there's -120, and here's +240. So they end up in the same spot. So the reference angle is just this little angle between the x-axis and the terminal ray. So in this case, since going this way is 180, and we know the whole blue angle is 240, 240 minus 180 will give me my reference angle of 60. I would say, if I had to guess, the coterminal is more important to know for your test than is the reference angle, but pretty simple to find. So now 8 says, find the 6 trig function values for the angle theta. That's -120. So we're trying to find what's the sine of -120, what's the cosine of -120, what's the tangent of -120, and then I could, of course, flip them to get the cosecant of -120, secant of -120, and cotangent of -120. Now on my unit circle, I do not see -120. I do see 120, but what I'm going to use instead is I'm going to remember we can use this coterminal angle. If we don't have it on the unit circle, we add and subtract 360 until we get to one we like. So if I look at 240 on my unit circle, that's somewhere down here. That's going to be at the point -1/2 negative radical 3 over 2. That's straight from my unit circle. You do not need to memorize the unit circle. We'll give you one on the test, but you have to know how to use it. So the sine is always the y value. So the sine is always second and the cosine is always first. So the sine is negative radical 3 over 2. The cosine is -1/2. Tangent, remember, is y over x. So negative radical 3 over 2 over -1/2. So the 2's will cancel, the negative signs will cancel. So we'll just get positive radical 3. And then for your last ones, you can just flip. So that's -2 over radical 3, that's -2, and that's 1 over radical 3. You can, of course, rationalize if you want, but those are our values. All right, so our last problem is just finding some exact values using the unit circle. So 5 pi over 6 and 3 pi over 4 are both on your unit circle. 690 is not, but we can use it. So if I look on the unit circle for 5 pi over 6, I get negative radical 3 over 2, comma 1/2. That's straight from the unit circle. Make sure you're looking at your unit circle, seeing where I'm getting this point, but this is the point at 5 pi over 6. So now if I'm looking for the cosine, cosine is the x value, so this is simply going to be negative radical 3 over 2. And that's my answer. Now for sine of 690, I do not have 690 on my unit circle, so I'm going to go ahead and subtract 360. So the sine of 690 is the same as the sine of 330. And 330 is on my unit circle. It's way over here. So if I look at that point on the unit circle, that one should be radical 3 over 2, comma -1/2. And since it's just the sine is the y value, the sine of 690 is just going to be -1/2. All right, finally, tan of 3 pi over 4. 3 pi over 4 is just on my unit circle, and it is negative radical 2 over 2, radical 2 over 2. Make sure you look at this. This is in quadrant 2 at 3 pi over 4. Tangent is y over x. So we're going to take radical 2 over 2 over negative radical 2 over 2. So the 2's cancel, the radical 2's cancel, so I end up with -1 because that negative did not cancel. So hopefully this is helpful, kind of brings back some of the problems we've done in this chapter, getting ready for your test.